Hi, and welcome to the final video in a 6-part series explaining how to quickly deploy a powerful, fast, and scalable data analytics solution using the free components of the Elastic Stack. If you haven't already watched the previous videos, I encourage you to do so first. In the previous videos, we demonstrated what this entirely free technology stack is capable of through a simple demo deployment. In this video, we'll briefly discuss next steps in scaling this up to a more production-grade cluster, and then explore a few more advanced capabilities that are generally not free, but which illustrate how the analytics platform can grow with you should your requirements become more complex. We'll be focusing on just the Elastic components, since that's the focus of this series, but it's worth pointing out that MongoDB, which we discussed in previous videos, has its own options for production deployments, as well as some powerful, though less user-friendly, analytics capabilities of its own. The lowest cost per gigabyte way to deploy Elasticsearch is to host it yourself on-premise. For this, you'll need to invest in multiple servers to form an Elasticsearch cluster. The most appropriate production architecture will depend a lot on your scale and business requirements, so I'm not going to go into too much detail here. But I will say that for medium-scale situations which are not business critical, an economical approach I've found is as follows. First, buy several entry-level bare-bones desktop servers, such as this HP ML30 desktop server. The important thing to note here is that it has a 64 gigabyte max memory capacity, which is recommended for Elasticsearch. It's pretty affordable, though note that this does not include any disk, nor does it include all 64 gigs of RAM, only 4 gigs. It does include a fairly basic Xeon processor and a power supply and, of course, motherboard. There are, of course, other options you can consider as well, though note that a lot of these, especially the smaller form factor ones, do not allow 64 gigs of RAM, so I would recommend making that a minimum requirement. So once you have your servers, the next step would be to max them out with 64 gigs of RAM ideally, and then install storage. Now, unless your dataset is extremely large and you're not too concerned about performance, I would recommend going with SSDs. You can use SATA SSDs, and they are going to be more affordable per gigabyte. However, for performance reasons, and given the fact that the prices are really pretty reasonable at this point, if you can, I would recommend going with NVMe SSDs. These are going to require a PCI Express adapter as well, which are pretty affordable in order to install it to our bare-bones servers. So depending on how much storage you need, you may want one or two of these. And 512 to a terabyte is a pretty good size range for the data sets we're talking about. Alright, once you've installed all your hardware, it's time to select an OS. As we mentioned earlier in the series, for production you're going to want to deploy to a Linux server, and CentOS is a good option for that. And for this, all you need is the minimal installation. This will not have a GUI-based desktop environment, which is fine because you're not going to be doing too much in the OS except installing Docker. To install Docker on Linux, they have instructions specifically for CentOS, so just follow these steps to set up the repository and install Docker. Beyond that, the command line is basically the same as what we've already seen in this series. Now, when you deploy Elasticsearch in production, you're going to need a little bit more configuration to make it perform well. And they have a whole page talking about how to install Elasticsearch with Docker, and they address doing so in production. There are a number of things to do, such as configuring some settings in the OS, as well as adding additional environment variable settings to your Docker run command. Now in this document they talk about using Docker Compose to set up and spin up your instances, and that is a generally good idea to spin up a bunch of things, but you can also totally do it the way we did in the earlier demo, just by adding additional settings to the run command. Now in production you want to deploy Elasticsearch to a number of different servers or nodes, which are combined into a single cluster. This provides you with better performance because it can distribute workloads across multiple data-bearing nodes. It also provides the option for data redundancy, which gives you fault tolerance in the event that you have a hardware failure. And because of this, depending on how sensitive you are to data loss, you may be okay not having disk redundancy or a RAID configuration on each individual node, because the Elasticsearch configuration itself will handle the replication for you. So if you lose just a single server, you should still be okay. Now obviously for mission critical data sets you're going to want more redundancy than that, and again you can achieve this in multiple ways. You can RAID your storage. You could also have more than one copy of the data distributed amongst your Elasticsearch cluster. And the only consideration there is obviously you will need more servers with more storage to handle that additional storage capacity. So this Docker run command is basically similar to what we started with, but with some additional options, and we'll just go through them real quickly. So this restart always option is just a Docker command that tells it anytime the Docker service restarts, or anytime this particular service or container has an error and it fails and shuts down, it will restart it automatically. Now for Elasticsearch, this is handy because sometimes you'll run too heavy weight of a query and it'll actually crash the server. This is less common with a well-tuned production deployment, but it can still happen. And by having restart always, that'll ensure that it automatically reboots and comes right back up. We're going to map the ports to the default ports again. We're only going to run one Elasticsearch instance on each server, so we don't have to worry about reconfiguring the port numbers. We'll just use the defaults. We'll use a Docker volume like we did before, which will handle our data persistence locally. Note that you'll have to configure this a little differently if you have your data drive separate from your OS drive, so just keep that in mind. We're going to again disable the XPack security like we did in our earlier demo. We're going to add some additional settings for production, which basically just improve its stability and performance. We're going to give it a cluster name of Elasticsearch, and that's going to help us kind of bind these together into a single cluster. We're going to tell it what our other hosts are. So all the different Elasticsearch servers should be spun up and then given a list of the other hosts in the cluster so they can find each other. And they should all have the same cluster name. This ES-Java options basically configures the amount of memory that the Elasticsearch service will use, and the general guidance is that this should be set to half of the available memory in your system. So for our system, which has 64 gigs of RAM, these should be set to 32. And then these other settings are also recommended for production. And then finally, it'll detach and pull the same image that we used earlier. So there are other options that you may need to configure depending on your deployment, but for the most part, this is kind of the minimum set that you should expect to do for deployment, for production. So I mentioned earlier that one of the benefits to having a clustered configuration is to set up redundancy in Elasticsearch itself, and that is configured on a per index setting basis, and there's just a simple HTTP endpoint that you can use to specify your settings for your cluster. Or for your index rather, and the number of replicas is the setting that you would want to increase the number of copies of the data. So the default is 0, 1 would mean all your data is copied once, 2 would mean it's copied twice, just gives you different levels of fault tolerance. Now it's worth noting that while replication will require you to budget for additional storage to handle these extra copies of data, that investment is not all wasted because the queries can be serviced by both the replicated data as well as the primary data. So if you end up having extra nodes in your cluster to handle this extra replication, you will get benefit from those extra nodes in terms of query performance. So that is an advantage to keep in mind. Another setting that they mentioned here that's worth pointing out is this refresh interval. Now in our example, we set this to 1 minute, and generally it's a good idea to set this to something not default, which basically means that it will not refresh the entire index and the data that's available when you're viewing things in Kabana every single time something is written, but rather it'll do it in batches. And so depending on how fresh you need your data and how fast your data is coming in, this can be important to reduce load on the server. So 1 minute, 5 minutes, an hour, depending on your workload, might be a good refresh interval. 1 to 5 minutes is generally pretty good unless you have to have it, absolutely real time. And again, that just means fewer times that it has to refresh itself every time something new is inserted. Now on the topic of deploying Kabana, the requirements are relatively simple. Kabana should have a decent amount of RAM, maybe 1 or 2 gigs per instance, but it really, for the most part, isn't working all that hard. Most of the work is done on the Elasticsearch cluster, and so you can actually run multiple Kabana instances on the same server, no problem, as long as it's just a basic PC. And the advantage to running multiple instances of Kabana is that you can have a different environment configured for different audiences. And so this is a nice way to sort of prevent one group or one person's saved visuals and dashboards from cluttering the view for everyone else. So if you have different types of audiences, maybe you have your IT folks need to use Kabana to monitor the state of the data and identify issues. Maybe you have analysts that want to be creating visuals and dashboards. And then maybe you have just sort of lay people who just want to be able to poke around. You can have a different configuration of Kabana for each of those audiences, and you can keep all these saved visuals and everything separated between those. So that's a nice architecture that I think is a pretty good idea. And because we've been using Docker, that gets really easy to run multiple instances of Kabana on the same server. And so an example of how you would achieve that, so here's a production-oriented Docker run command. So we're going to give the name of the Docker instance something a little bit more specific now. We're going to call it Kabana General in this case. We're going to map it to port 80 on our server this time, which means that you can see this instance just by going to our host name in your browser without specifying a port, because 80 is the default port. So this is a good sort of general configuration for, most of your viewers or your main audience should get the port 80 experience, so they don't have to remember a port number. We're going to specify an Elasticsearch URL this time. So because this is not running on the same server as our Elasticsearch server, we now need to tell it what the host name is on the network. So the Kabana index is important for this, because this is actually how we segregate all of our settings, our saved visuals, and everything. So Kabana stores all the stuff, all the settings that you make in the Kabana UI, including saved visuals and stuff, in a Elasticsearch index that it creates for itself. And by default, these are always called .kabana. But by specifying a different Kabana index, you can create a sandbox for just this instance to use. And so we'll give it a non-default name, in this case of Kabana-General, which will be different from the index that our other instances will be using. You can optionally give it a server name, which just makes it a little bit nicer in the browser and saying what the app is called. And then again, we'll keep security disabled for now, and then point it to the Kabana Docker image. So for another instance, all we'd have to change is just a few things. So running on the same server, we'll need to give it a different port mapping. So we're going to do 81 now. We'll give it a different name so this container can run on the same system side by side, and we'll call this one Analysts. And then again, we'll update that Kabana index now to Kabana Analysts. And it's pointing to the same Elasticsearch host name, because we only have one Elasticsearch cluster, only one copy of the actual data, but multiple instances of Kabana all pointing to that same cluster with their own configurations. So this only scratches the surface of the various configurations that might be needed to have an optimal production deployment, but it should be enough to get you started, especially for simpler, less mission-critical scenarios. Of course, if you have a bigger budget or not a lot of data, there's also the option of a cloud-hosted subscription. There are a number of options for this, including one from Amazon's AWS and another provided by the Elastic company themselves. The Amazon service comes with just the open source services, so Elasticsearch plus Kabana, and it also has the issue of not always being kept up to date as quickly as Elastic's own service. So for the most part, you probably want to gravitate toward Elastic's first-party hosted option. So if we go to the Clouds page and we click on the Elasticsearch service, we can see some information about their pricing model, as well as subscriptions. Now, subscriptions refers to the different levels of features add-ons that you want, and we'll talk about those in a little bit. As far as pricing goes, they have a free tier, which is really bare bones, enough to just kind of play around. And then they also have some pretty affordable places to get started. So if we click their launch pricing calculator, we can see that the kind of most bare bones deployment is only $16 a month. Now that's only giving you a couple gigs of RAM, not a lot of storage, but depending on your use case, that might be enough. It's also worth noting, and I'll go back to that subscriptions page, that although for the most part features like machine learning and graph analytics and some cool stuff like that require a fairly expensive paid subscription, if your cluster is using less than 64 gigabytes total across all nodes, they actually throw in all their Platinum features for free. Now, they may not do that forever, but at least for now, that's a pretty compelling argument to consider the hosted option if your data set is small enough to be okay with a total of 64 gigs of RAM. So before we wrap up, I want to talk a little bit about some of the add-on options that you can use to extend the functionality of the stack. So most of them are provided through some of the paid subscriptions provided by the Elastic company, but there's also some third-party options as well that could be interesting. So on Elastic's website, if you click on their subscriptions link here at the bottom, they have a breakdown of their different subscription plans. So under free, they have both the open source code as well as some additional not open source but free features that they provide, which are available in their default Docker containers without any extra work. And these involve kind of all the typical basic stuff that we've seen, including most of the Kabana functionality, your index settings and filters in Kabana, some basic monitoring stuff, etc. Share includes the ability to export CSVs, things like that. But if you move up to some of their paid plans, you can add additional functionality. So some of the more interesting there are security. So out of the box, there is no ability to secure your Elasticsearch cluster for free. And so that is something to keep in mind if this is sensitive data. Obviously, if you're hosting this internally, it's going to be limited to your whoever is on your intranet. But beyond that, if you need extra access control, you're going to have to look into some additional options that are generally going to cost money, though we'll talk about one free option in a moment. But if you move up to their subscriptions, then you get things like LDAP logins, role-based access control, so you can lock certain indexes to certain users, things like that. You can also add machine learning capabilities, which we'll do a quick demo of later. But this is an interesting area that they seem to be investing a lot in, and so it'll be interesting to see how their offerings in this area expand over time. You also get some additional capabilities. For example, they just recently released a JDBC driver for their new SQL interface for Elasticsearch, so that could provide some neat integrations into third-party reporting tools that are built around the SQL language, although keep in mind that it's not going to be a full-fledged SQL implementation. It won't have all of the capabilities of a SQL database. You've got monitoring and alerting capabilities and things like that. So scroll through this to see if these paid options might be interesting to you. Before we move on, though, I do want to talk about one other provider of add-ons that's interesting. So Read-Only Rest provides a couple of options for security. So they have a free option, which is open source, that allows you to secure your Elasticsearch cluster and Kabana, and has all kind of the typical authentication methods that you would expect. Again, I haven't used this, so I can't vouch for how nicely it integrates, but it is free, so it's definitely worth looking into if you're on a budget and you need to secure your cluster. If you're willing to consider their paid plans, their enterprise subscription includes some pretty neat features that aren't even included in Elastic's security module, including multi-tenancy and the ability for different users to have different dashboard experiences. And so they basically implement this via the same way that we talked about earlier, where they create a different Kabana index for different users and different roles, but it's baked into the UI, so you have the ability to kind of switch between roles or users to get different views and have that based upon your login, which is kind of nice. So if that's worth it to you, this could be an interesting option. And again, it does provide some functionality over and above what Elastic provides. Speaking of Elastic, and so if you go to their products page under features, you can see more of a description around some of their paid offerings. And a few of these have some limited functionality for free, like monitoring and Elasticsearch SQL. are available in a limited capacity without paying for one of their subscriptions. But to get the full suite of features that they provide does require subscribing. So all of the paid features are actually included in the default distribution of the Elastic Docker container. They're just disabled, and you have to enable a trial before that you can make them work. So you can come into management, license management, and you can start a 30-day trial, which will provide all the platinum features. So we'll go ahead and activate that. And just like that, we have some new apps added to our Kabana environment. So if we click on one of these, machine learning, we can start to explore one of their more advanced features, which to continue using you would have to pay for. So let's explore the machine learning feature a little bit. So this is built really for infrastructure monitoring use cases where you might be ingesting a bunch of logs and you want to identify anomalous behavior, whether it's weird user activity that might indicate some botnet attack or something, or a security breach, or downtime, some servers that are having extra latencies, whatever it is. This feature is really intended to help you identify those things quickly by modeling past behavior and identifying sort of what looks like unusual behavior and being able to flag and alert that proactively, as well as some predictive features so that you can sort of plan for maybe infrastructure upgrades, things like that, based on past failure rates and behavior. So it's not really built for the sort of data we're dealing with, but we'll just see what it can do. So we'll start with a single metric, which is kind of the simplest case, and we'll use an average of temperatures because that's what we've been doing. We're going to bump up our bucket span to 60 days, and I found that I had to do a lot of kind of playing around with these spans and the time ranges to get this thing to work as expected, to actually flag anomalies. So I don't know if that's just because this temperature data and the time ranges I'm dealing with and just the behavior, the density of the data is not really what this is optimized for, or what. But I will say I found it to be a bit finicky, and these are some parameters that happen to work reasonably well. Another thing I'll point out is that my time range is set to the last 45 years, and that's because the machine learning only works on data since the Linux or Unix epoch, which is back in like 1970. So we are, in our case, limited to a recent subset of our data, but most data sets aren't gonna be an issue because you're not dealing with data from decades ago. All right, so we'll go ahead and create this job. It's quickly evaluated or analyzed the data. It's given us some sort of real-time feedback as it's running, that it's finding some anomalies, and we have a job created. I'm not going to check this continue job in real time, although you might want to do that if you have data sort of coming in a live fashion. We don't, but if you did, that would be valuable to be able to flag anomalies as they happen. So let's view these results. So in the single metric viewer, we're now looking at kind of our average temperatures plotted, and then overlaid on that are these sort of ranges that are based upon the model that it created. And presumably they're really wide early on because it hasn't processed enough data to really get any confidence, but at a certain point those ranges tighten up and we have a more realistic sort of error bound or a range of expected temperatures. And if we zoom in here, we can see that it's flagging some anomalous temperatures. And so in this case, September 28, 1987, if we come down here, we can look for that. Here it is. It flagged it with a pretty high severity, and it said the actual temperature was 10 degrees, but typically it's 12.5. So it's actually unusually low for that month, essentially, or that's, I guess, 60-day period in our case because of the span that we have. And so it's just identifying some temperatures that are unusual. And again, it's comparing Septembers to Septembers, so presumably other Septembers were typically a little bit warmer. It's a little hard to see that in this chart because we're looking at cyclical temperatures that fluctuate throughout the year. So again, this isn't super maybe applicable to this data. I mean, I was hoping it would be interesting at finding some more recent anomalous years, but I think it sort of expanded the expected ranges proactively, and so even though we have been having some extreme temperatures more recently, they're not outside of the model's sort of range of expected. And that's a little bit interesting actually, because the model sort of adapted to, I guess, presumably a changing climate in the case of this data, and is therefore a little bit more lenient about what it considers an anomaly. Now, I'm not going to get too much into the more advanced types of jobs that you can run. Multi-metric is interesting in that it'll let you do sort of the same sort of analysis, but on your data split up across some dimensions. So you could split it up by country or something and do this analysis on that. You can also tell it what fields are influencers, which sort of helps it determine what things to watch out for that might be correlated with anomalies, to help you quickly zero in on why some temperature range, in our case, some temperature was out of the norm. What was the thing that influenced that? If we had sort of information in our objects that we thought was correlated with anomalous behavior, we could select that type of information here. But in my experience, this wasn't super useful for our data, but something to be aware of that might be useful in your case. So I hope this video series was useful to you, and that you've got some neat ideas for ways you might be able to extend your data analytics capabilities by using the free components of the Elastic Stack and perhaps throwing Mongo into the mix as well. If you'd like to use my Python script, feel free. It's all MIT licensed and you can basically do whatever you want with it. And hopefully the information in this series has gotten you started down a path of making better use of your data. Thanks for watching.